get started here. So I think one of the best things to do here is just to have you look at the question when that loads up here. Before I sort of give you any hints or talk about any sort of approaches here. This one, yeah, go ahead and take a look at it. And I'll just jump in here in a bit if needed.
So would this one be? I want to say it's A because it would be the dollar times how many there are because it's $1 for each.
Yeah, so
No?
$1, you know, is X francs.
Oh wait, never mind.
I'm
thought X
just
was the dollar.
okay. Any ideas here? Anything come to mind?
I guess D just because it's the only one that has a 1 in it.
Okay, I can see why you would go that direction. One of the things they talk about as far as like a test taking strategy is to substitute numbers, like, but ones you never seem to use are 0 and 1. So you don't want to use that. But like, let's say you want to, you know that, like, for example, $1 is worth 5. You just make that up, French francs. Okay, so $1 is 5 French francs, and we got to pick a different number for Y. And let's just make it 20. So 20 French francs. Okay, we know 20 French francs is worth how many dollars here? Basically, I'm asking, how did you go from 5 to 20? What did you multiply by? So times 4 there. So 5 times 4 gets you to 20. So you multiply if you multiply this 1 by 4, you get $4. Okay. So that's the answer. Now the question though is how do you get $4 from 20 and 5? Well, you take the 20 and divide it by 5. That equals 4. 20 was really Y. X was really 5. So it's Y over X. Letter C. So the approach here is to test numbers, but you have to test numbers that make sense. Meaning, like, don't use 0 and 1. Use like them a little bit further apart. Numbers maybe you're comfortable multiplying or dividing. So maybe you weren't, for example, comfortable multiplying or dividing on that one. Any questions on that? Okay, so here's another problem to look at. All right, again, probably have you take a look at this. What is the area and square graph units of the triangle?
I don't know. I haven't seen anything like this yet.
Okay, do you remember any formulas for the areas? Okay, so the area of triangle is the base times the height divided by 2. Okay, so the base is what it sits on. It sits on this one up here. Okay, so the base in this problem would be 4. The height is, well, it's the vertical distance. So notice this 8 is not the vertical distance. It represents the kind of this length here is the 8. You want this height right here, this vertical distance. How can you get that?
Eight times 4.
So like the thing about the base is just counting, right? 1, 2, 3.
8 plus 4.
Well, we just want this red line. We just want to know the vertical height. So you just sit there and count, 1, 2, 3, 4, 5, 6, 7, 8. So the base in this problem is 4. The height is 8. And you divide by 2.
Okay.
So in this case, 4 times 8 is 32. 32 divided by 2 is 16. Any thoughts on that? Questions?
Mm-mm.
Okay. I think the idea is that, if you do enough of these problems and you start seeing them more than once, you realize, okay, it's one of those, I do this, it's one of those, I do this. And take a look at this one here. All right, so at a certain time of day, a man 6 feet tall casts a shadow 4 feet in length. Okay, at the same time, a church casts a shadow 28 feet in length. How high in feet is the church steeple?
Mm.
Any idea how to proceed here?
Wait, 32?
How did you come up with that?
Just because
I'm not saying you're wrong, not saying you're right. I'm just asking because there's many ways to do this problem.
this only other thing on there is a 6 and the 4, and it would be like, or it was 4, right?
The man is 6 feet tall and the shadow is 4 feet. And then the church, we don't know its height, but it's 28 feet is the shadow.
So it'd be 30.
Well, okay. Yeah, I'm asking you kind of what your process is here to do it before I either hint at it or not.
Because I figure it would be the same amount of feet away.
Okay, so and that's why that answer is there. That I can see that now, why that would be there. These are triangle relationships. So think of the man. The man is 6 feet tall, and that's his shadow. And then the church, we don't know its height, but we know that it's a 28 foot shadow. So drawing a picture here can really help. Can really, really, really help. But you got to know the picture to draw. So whenever you see shadow problems like this, I don't know why I'm having so much trouble here. Whenever you see shadow problems like this, you want to draw some triangles. Okay. So which lengths on this do you see that might be related? Like, is the 28 related to the 4 or is it related to the 6?
The 4?
The 4, because they're both shadows. All right, so what you can do is make a quick assessment, like how do you go from 28 to 4, or how do you go from 4 to 28? Basically, you decide which direction you want to go here. And you're always multiplying in these problems.
So what do I do then?
Well, that's what I'm asking you. How do you go from 4 to 28? What do you multiply by to go from 4 to 28? Or what is
8?
28 divided by 4? Yeah, so 4 times 8 is 32. Okay, and so you're multiplying by 7 to go from 4 to 28. And so the idea is that to go to H, you're also going to multiply by 7. So that's way number 1. So can you tell me what 6 times 7 is?
Not off the top of my head.
Okay, so what I'm seeing just through a couple of problems here, and we saw this back in, like what is 20 divided by 5? You want to get really fast with your multiplication and division tables. That's going to help you here because these aren't big numbers, but they're big enough that you want to do them pretty quickly if you can. So 6 times 7 is 42. Okay, so that's kind of way number one to look at this problem. Let me grab the problem again and give you way number two. So again, I'm going to label the triangle here, man, 6 feet tall, 4 feet in length, or a shadow. The church is 28 feet. So kind of similarly here, you can go from 4 to 6. Okay, meaning like how do you go from 4 to 6? Well, if you double 4 doubled is 8. That's too big. But 50% of 4 is 6. Or 2, which gets you to 6. So another way you can do it is think of it as like it's 50% bigger. Is one way to look at it. You can think of it as being multiplied by 1.5. That's what 50% is when you multiply by 1.5. And you can use the same relationship here. Right? So like 50% of 4 is 2, 4 plus 2 is 6. If you can figure out 50% of 28, you can add it to 28 to get h. Does that at all make sense or not?
No.
No. Okay. All right. We should do some more similar triangle problems. Let me go quickly scour the internet here for a few similar triangle problems. And then I think this will make more sense.
I hadn't gotten to any of this yet. This is at the end of the book after all the polynomial stuff.
Okay. Yeah. And you don't want to these are just proportions. These are not like, I'm saying similar triangles because that's what they are, but they're more just proportion problems that are really not that bad once you see the pattern here. So let me see if I can find a couple here. Let's see here, solve similar triangles, worksheet. Okay, here we go. All right, so here are two triangles that are similar. The one on the left is similar to the one on the right, okay? And the idea here is that these sides are sort of linked up. So this 5 centimeters is linked up with this 25 centimeters, okay? And you have to say to yourself, well, how do I go from 5 to 25? And it's always, you're either multiplying or dividing. Okay, so that's where you got to be real fast with, multiplication division tables. 5 times what gets you to 25? That's
5.
5. Okay, so here you're multiplying by 5. So similarly, if you wanted to go from 6 to this side over here, you will also be multiplying by 5. So what would that be?
6 times 5.
Yes.
What does the AC mean now?
I'll get to that in a moment. It's just referring to this side down here. I was just gonna have us solve all of it before so we get the practice. AC, it should actually have a line above it because it's a line segment. All right, so 6 times 5?
30.
30, good. Okay, and then now AC, if we knew the value of AC, we could get to 20 by multiplying by 5. So to go the other direction, you have to divide by 5. You undo division or multiplication with division.
What are you supposed to do?
Well, when we went from the left one to the right one, you multiply by 5. 5 times 5 is 25, 6 times 5 is 30. We don't have AC though, so we don't know what we're going to multiply by to get to 20. So to go backwards, you divide. So 30 to go backwards to the 6, you're dividing by 5. The 25 to go backwards to the 5, you're dividing by 5. So this length right here, this AC, you take the 20 and you're dividing by 5.
And is that all you have to do? What about the
Yeah, and that's what I'm at. Yeah, I'm trying to get you to give me that value here along the side here.
4?
4. Yeah. Okay. All right, so let me give you maybe a new problem here to look at. Recently figured out that I could draw triangles here. Amazing. I don't know why it took me so long to do this, but let's say these triangles are similar. Let me make them actually a little smaller here. All right, so let's say this side is 3 and this side is 12. This is 4 and this side over here is 20. Okay, so we can label these if we want: A, B, C, D, E, F. So you want to think about, well, how do you go from 3 to 12? What would you multiply by to go from 3 to 12?
4?
4. Okay, so you might even denote that here. Okay, times 4. So that means you have to take this 4 here and multiply it also by same value, the 4. So what would EF be?
I can't see the other side of the other triangle.
Okay,
What was the other number?
let me see what you're seeing here. It's 4 on the BC side. I'm showing you're seeing my full screen. I'm not, maybe you're zoomed in or something.
There you go.
Yeah.
Oh, you put it on the bottom. I was thinking it was on the other side.
Right, so we want to use this 4 to get this side over here, also going to multiply by 4.
So do I just do 4 times 4?
Yep. So 16. And then kind of just like the last problem, right? It's like if we knew the side, we would down here, this AC, we would multiply by 4 to get 20. Since we don't know it, we have to undo by dividing.
Do I just divide by 4?
Yes.
What was the point of the 3?
I'm just giving it to you. I have to give you enough values to be able to figure it out.
Oh,
Yeah, nothing mysterious about that. Okay, let's assume you've got a calculator for the next one here, because it's kind of a story problem that so let me snip this in here. All right, so let me cross out some stuff. Forget about this down here. All right, it says 2 buildings stand side by side. The shorter building at 60 feet high, okay, casts a 48-foot shadow. All right. At the same time of day, the taller building casts an 80-foot shadow. Okay. What is the height of the taller building? So what you're trying to figure out is, how do you go from 48 to 80? 48 to 80.
how will I know it's asking me to do this in a word problem?
This is one of those shadow problems. So you're gonna you want to associate shadow problems with triangles and proportions. So, so the idea is that like like in the past you've been able to just like multiply, like, okay, it's like you could see it like, all right, 48 times 2, but it's not. So you generally take the larger number and divide it by the smaller number. Okay, so like I said, let's assume this is a calculator problem here. What would be 80 divided by 48?
Let's see. But it's like 1 point, a bunch of stuff.
Okay, give me the bunch of stuff. What do you see there?
I would put the 80 in the calculator first, right?
Yes.
Okay, just
Yes.
making sure. It's like 1.6666
Right, 6 repeating.
6667. So
So
it would have, you just do 1.6 and then like a continuous. I don't know how you'd write that.
yeah, you can do that. That's not really all that important, but this is correct. Let's just use 5/3 for the moment, but that's fine. You're going to use that. That's your multiplier. So 48 times 5/3, or 48 times this 1.6 repeating, is 80. Okay. So that means you're going to use that multiplier for this other one. You're going to take this 60 and multiply it by the 5/3, or the 1.666 repeating. So will you do that for us, please?
60, 100.
Yeah, 100 feet. Right. Okay, let's go back and just grab some new questions, if you don't mind. It does seem very geometry heavy at the moment, but that's okay. It's totally okay. All right, let's do another problem here. Just kind of picking different topic areas, nothing in particular here. So it says, what is the median value of this data set right here? Okay, so this is where you need a little bit of background information. You know, maybe you haven't seen median in a while. Median is the middle number. There's always a middle number. Okay, and the thing that you have to do here is you have to order the data set. Okay, smallest to largest is preferred. Smallest to largest. Okay, now what I recommend doing is when you grab a value like 268 is the smallest value, you cross it out. So you know 268. Then you look for the next smallest value, which looks like 654. Cross them out as you go so you don't double use them. Then 852. Then it looks like 900. Then it looks like 1,258. And notice that appears twice. You're going to write it twice. And then the last number is 1,558. All right, so now let me count the number of numbers here. There are 1, 2, 3, 4, 5, 6, 7 numbers. Which is the middle number?
900.
900. Okay, so you have to remember that median is the middle number. Do you need a calculator to do this?
Mm-mm.
You do not. All right, now let's talk about the other thing they're going to ask you about, which I will change. One word. All comes down to one word. What is the mode of the data set? Mode is the one that occurs most frequently.
That's the 1258.
That's the 1258. Very good. All right, good. Very good on that. Here's another mode problem for you to look at. All right. What is the mode of the following data set?
14.
14. Very good. 14. All right. New problem here. All right. Charlie borrowed $1,500 from his aunt. He's got a nice aunt. He plans to pay his aunt back in 9 months. If he pays 4% interest on the loan, what is the total amount he will pay back in 9 months?
I
All right,
remember this one, you had something to do with like it had to be in years, so 9 months would be like a fraction of the year, and then you would have to
yes.
what else do you do?
Yeah, give me, so here's what, this is what's called a simple interest problem. And it has a formula. The interest that is earned is the principal times the rate times the time. So P stands for the principal, that's the loan amount. R is the rate, but it's as a decimal. And T is the time, as you just mentioned, in years. So in this problem, the principal is 1,500. The rate is 0.04, and the time is 9 months out of 12. All right. Trying to decide here if they would actually allow you to use a calculator on this. Probably. Do you want to try calculating this?
I'm not. I would have to change the fraction into a decimal because I only have my phone calculator.
Okay, so let me drop this in the chat. This is a really good calculator to use for just basic manipulation like we're doing here. You can enter it exactly the way you see. It's also available as an app if that's useful to you. So let me snip that in. So you can actually type it basically the same way you see it written here. I have it out of order because I was.
What is it?
This is how you enter it. I put it in the chat. It's just a online calculator that's really good for entering these calculations.
Mm. Mm. Is it a 4 or 9? It's a 9, right at the top.
Yeah, 9 out of 12.
9. To the top. Uh-oh, hold on. So 45?
45, yeah. Now notice that none of those have 45 in it because it's the total amount that he's going to pay back. He has to pay back the original amount.
Yeah, you have to add the original amount to it.
Yeah, you have to add them together. So 15, 45 for that. All right. Let me change the numbers here just a tiny bit. Have you do another one of these? So let me grab this.
What does the P stand for again?
Principal, so it's the loan amount.
Okay.
All right, so let's say 2,500. Just forget about these answers for a moment. Let's go 6%. He's going to pay it back in 15 months. So if you could just do another calculation for me just to get comfortable with this?
Mm. So it would be 2,500 times.
Yep, the principal times the rate times the
And
time.
then it would be 0.06, right?
Okay.
Because you would move it two spaces
Yes.
over, right? Okay. And then time. It would be 1, and then let's see, 3 out of 12.
So your principal P is 2,500. Your rate is 0.06. What's the time in this case?
Because it's 15, so it would be 1 and something, right?
You can go 15 divided by 12, or the number of months divided by 12. So you don't have to,
Oh, okay.
you don't have to
I
like,
thought since it would turn into like a whole fraction where it would spill over, so it would be like 1 and 3 out of 12.
it is, but the calculator will handle all that for you.
Okay,
And I think there's
that's
some
convenient.
reasonableness that you will have a calculator on a problem like this.
So 120,
You've
but
2,500 times.
then you add to it, but that's the
Now
whole thing.
I've
Or
got a
no?
different.
Oh
I've got
wait,
a different.
no, I mixed up the 12 and 15 because the 5 and 2 look alike. I put the 12 on the top.
Okay.
So
Yeah, go
it'd
ahead.
be 187.5, and then you would add the original to it again.
That's right. That's right.
Oh, that didn't work right on the calculator.
It's okay. I mean, this would be multiple choice. So it'd be 2687.50. All right.
Okay,
So here's a new problem for you to think about, look at.
yeah. Point. Uh-oh.
Okay, I'm back.
Huh? Okay.
Hey, sorry about
I
that.
didn't notice that you dropped it first because the screen didn't go away at first.
Oh, nice. So any idea how to work this one through?
Um, so I guess I'd be finding the part, like how many of them were adult. So wouldn't I would do like 0.80 times 650
Yeah, now this
or
one
point 0.8.
yeah, I mean, you could use a calculator, but this one is probably meant to not have one. Um, One thing you could do though is work it kind of backwards, like what would be 20% of 650?
Or I could do that too. I was just gonna figure out how many were the adults, and then I was going to like minus whatever would have been the rest of
Okay,
that from 650.
that's
But
fine.
yeah,
Yeah.
that would be the same way. I could do it
You,
that way too.
yeah, you do it however
So
you
you could
think will
do
be best.
point two times 650, and that will give you your answer, right?
Yes. Do you have an answer for me, or do you need some help here? How to calculate this?
Is it 130?
Yes.
Okay.
All right. Okay, so here's a problem that should look familiar. We did a bunch of these the other day, last time we met, and they're really good about being like they're consistently, you'll see these types of problems. It's another actually like proportion problem, like a similar triangle kind of thing here. So on a certain map, 1 inch represents 60 miles. Okay. And the towns are 255 miles apart. Okay. So I kind of like drawing these sort of like progressions for there. But if you think of it in terms of a triangle, it's like the little one, 1 inch to 60 miles, and then the big one is 255 miles. Now this one's a little bit harder to just go from like 60 to 255. That's going to be tough. But you can see all the answers have a 4 in there. Okay. And that's like a test taking strategy. You look at the answers and you're like, okay, what's the same? What's different? Well, they all have a 4 in it. Okay. So we know it's at least 4 inches, right? So if you take the 60 here and you multiply it by 4, can you tell me what that is?
Mm,
If it, and if you're not sure, you can take the 6 and multiply it by 4 and put a 0 on at the end.
240.
240. So that's the 4 inches. Okay. But now how many miles are left over? How many miles do you still need to go?
Um, oh,
If
15.
yeah, 15 more miles. 60 miles is a full inch. How much is 15 out of 60?
I don't know.
So is there a number that goes into both of them? Can you divide both of them by, say, like 5 or 3?
5 maybe?
Okay, 5 definitely works. This is where that, that little practice there on getting your fluency on your multiplication division will help here a lot. So 3 divided by 12. Are these numbers divisible by anything? Is there a number that goes into both 3 and 12?
3.
3. So you can divide both by 3. That's 1/4. Is that there as one of the answers? Do you see that where that 1/4 has come from?
Kind
Kind of. Okay. All right. So let's go to some different problems here. Definitely want to spend some more time. So like when you said that class was doing fractions and percentages and stuff, they probably should have been doing a lot of problems like this, to really kind of hit home on these fraction concepts, because that's how they're appearing on the test here. All right, question 24 says cardboard crate is 5 feet long, 3 feet wide, okay, and 12 feet and 2 feet tall. What is its holding capacity? So holding capacity refers to its volume. Its volume here. So it's got 3 dimensions. 5 feet long, 3 feet wide, and 2 feet tall. Do you remember any formulas for volume?
No.
So volume is length times width times height. So what is the length in this problem?
Mm. 30.
All right, I'm back. I've got apologize for this. We'll just keep going here. Make sure we get plenty of problems in.
I'm not sure when you cut out. I said it was 30.
Yeah, so it's 5 times 3 times 2, it's 30. That's perfect. Okay. So you're going to see some, formula problems, length times width times height. And these are, going to be kind of like the area of a triangle. There's just a variety of these things that you might see. So let's go. I saw some other problems that were more based on graphs. So you've probably seen this style of question before. Let me grab it. All right, here we go. So this one refers back to this graph here. So there's a couple of questions that refer to this. So it's giving you the paint sales at a hardware store on day by day a week, and on the left here is the number of gallons. The first question there is just asking about how many were sold on Wednesday. What do you see there?
8. No, it's not an option. 6.
6. Yeah. So that's pretty straightforward, right? I'm surprised that they would ask that question, but here's another one that they might ask, which is how many were sold for the entire week. Okay. And this one's asking you to combine all the numbers. Okay. So it looks like, and then maybe it's hard to see here, but Monday is actually at 5, Tuesday's at 4, Wednesday's at 6, Thursday's at 5, Friday's at, you gotta be, looks like 14, Saturday's at 18. This is where it's like, it's easier when you're on there. I think that's 10, something like that. So you could add up these numbers and you would get the answer there. This is probably a better example of what you might see. So let me just reset the problem with the graph, because it's all the real questions are asked you. They're sort of like, there's always like 2 steps or more, and you're going to see that here. It says, how much more paint was sold on Sunday than on Monday? So basically they want you to compare Saturday to Monday.
Is Monday like 5?
Monday's 5, yep. And Saturday?
And then Saturday's 18?
Ish, yeah.
But I put maybe like 17?
Yeah, probably
Nope.
17, just that works out a little nicer. So yeah.
So, let's see.
Or 17, 18, 17 minus 15 is.
Wait, 15? I thought it was 5.
5, sorry, I spoke the wrong thing. 17
Oh,
minus
okay.
5.
For a second, I was
Yeah.
wondering if maybe it was one of those ones where it was like compressed, where like it says a 5, but it really.
Yeah, no, it's me,
Yeah.
Matthew, being it's late for me, and I'm really frustrated about my internet going out in the middle of our lesson, so I apologize again. Here is another problem that you might see. It's got a pie chart. So the pie chart has percentages in it, and they should all add up to 100 total. And this one is really close. 36, 27, 28, 9. Yeah, so this one really close here. Okay. It'll be really close. It'll be like 99 or 100. It'll be pretty much spot on. If the client's monthly take-home pay is $2,500, so that, like, for example, housing would be 0.27 times 2,500 for housing. That's how you use the pie chart here. So they're saying if their take-home pay is 2,500, about how much they plan to pay each month on their credit card debt. Okay, so how much percentage is their credit card debt here?
24%.
Of 2,500. And then this one can kind of be estimated, I guess, but you probably would have a calculator here. So if you want to do this exactly,
600.
yes, very good. All right, let's look at so I'm going to snip in the pie chart again, and let me grab the next question for us here. All right. So this one says, what fraction of their take-home pay goes towards clothing? So clothing is 5%. They're basically asking you, where does 5% fall in here?
So it would be. I'm confused. Wouldn't that just be 5 out of 100?
It is. It is
And
very, it is,
then do you simplify that?
yes. So you can divide both of these by 5.
Does it end up being A?
Yes, very good. Great. Let's just say other was really 15%. What would 15% be as a fraction?
I don't know.
So it's 15 out of 100, right? Just like you told me.
Oh, okay, never mind.
Yeah.
I thought you meant like simplified
Well, yeah. How do we
or
simplify
something
this?
different.
Yeah. Give me the reduced form of this, please.
15 over 100.
Yes.
Three over 20.
Yes. Good. All right. So what I'm seeing here, and I'm just, I know you can't see this test. To me, it's a lot of these kind of numerical questions that we just been looking at, some geometry, triangles, proportions, a little bit of statistics, the mean and median, and then a little bit on like the equation of lines. So I feel like that covers it. So there's a ton of these tests. Let me stop the recording here.